Guys, in this video I'm going to discuss about method 2 for solving one-way ANOVA. So in the previous method we saw method 1, we discussed about how to solve the problem for one-way ANOVA. So for that, first we need to calculate the group means. So where it is icon, we need to calculate the group means for each group and overall mean. Again and again I am repeating, not necessary that all the group observation it should be equal 10 10 10. Is that it may be 10, it may be 5, it may be 6, or it may be 5, it may be 5, it may be 8, something like that. We need to be very careful in calculating the group means. And n is 10 here, n is 10 here, n is 10 here. But if it is different means according to that. Group means calculated, overall mean calculated. First step 1. Step 2, between groups, how to calculate between groups. Between groups, group 1, group 2, group 3. In the sense, overall mean is important. So overall mean minus group mean whole squared into n. Overall mean of group 2, overall mean of mean minus group mean 2 whole square into n plus third group. This method between groups. Within group, in the sense, group mean with individual cell value and whole square, the summation, group 1, group 2, group 3. So by adding that, we will be getting the sums of squares of error. So sums of squares of response we know, sums of squares of error we know. With that, we can able to calculate the mean square error with the degrees of freedom. Degrees of freedom we know, number of observation we know, k we know, n we know. So with that, k is what? 3 groups, so 3 minus 1. N is what? Number of observation 30 minus k will be degrees of freedom for the error. Degrees of freedom for the total, n minus 1, so 29. So the ratio between SS total divided by SST means SS treatment divided by degrees of freedom will give the mean square. Similarly, SS sums of squares of error divided by degrees of freedom of error will give us the mean square error. With the ratio between the mean square error for treatment divided by mean square error of error will give the value, calculated value. Then for the 2,27, for 2,27, if we refer 2,27, we refer, we get 3.3541, 3.3541, we got 3.3541. So that value which will be represented in this way, the value which we calculated is 2.358, which is within that bell curve. So we can say that there is no significant difference in the means, and there is means accept the null hypothesis and reject the alternate hypothesis. Accept the null hypothesis means means are same. There is no significant difference. Means group 1, group 2, group 3, even though we are teaching different methodology, their performance are same. That is what the outcome from that. Okay. So this is second method. In second method, how we are going to solve? Please careful. In second method also I given step-by-step method. So in second method, first we need to calculate the grand total. So all the things grand total, even though it's a 10 10 10, all 10 grand total. Then we need to count the number of observation. How many number of observation is there? Here assume equal, since it's equal is 30. If it is different means accordingly it should come. So number of observation and calculate the correction factor. So new term we are introducing here in the second method for solving one-way ANOVA is the correction factor. Why am I introducing here correction factor means it will be useful for your two-way ANOVA problem solving. That's why I am adding this method here for one-way ANOVA solving. So calculate correction factor. For that, how to calculate the correction factor? This is the equation, grand total whole square divided by total number of observation. So we know the grand total, this is the grand total 2574, whole square divided by total number of observations 30. So this value square divided by 30 will give us some value. That is what your correction factor. So once we calculated the correction factor, the step 4 will be calculating the SS total using this method. And step 5 will be calculating this SS sums of squares of between and within. So within also there, total also there. So once we know the total between within, we can able to make the F distribution easily. So what is this value here? C is the correction factor. In RSM, C is the step size, but in terms of one-way ANOVA, C is the correction factor. Do remember. So SS total is there, SS between is there, SS within group is there. So how to calculate? So first SS total. So this is the table. What is this? 85 whole square plus 86 whole square plus 88 whole square dot 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 up to 81 whole square. Means each and every cell's values square. 85 whole square, 86 whole square, 88 whole square plus 75 whole square plus 78 whole square plus 94 whole square plus dot 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 81 whole square. This one minus correction factor. The correction factor is what? Previous step, grand total whole square divided by number of observation. We got the value. So the difference between those will give us SS total. This is step number 4. Step number 5 is SS between group. How it is calculated between group? Between group means group 1 to group 2 to group 3. Method 1 is different. In method 2, means of the groups. So this is the means of the group. All this mean, all this mean, all this mean, or at least we can say mean divided by number of observation. Here 10 number of observation 10, here also 10 observation 10, here also 10 observation 10. If it is observations are different, accordingly you have to substitute here. That squared, like means squared divided by number of observation, that is summation of all minus correction factor. So this 834 whole squared by 10, 893 whole squared by 10 plus 847 whole squared by 10 minus correction factor will give you SS between groups. Now SS within group. What is SS within group? Difference between SS total to SS between groups, right? So SS total we calculated. SS between we calculated in the previous step. Difference between this will give us a within group. Previous method, first method we calculated between within also, but in this step we are not calculating the within, because with the correction factor we calculated the total and between group. Now we are calculating the difference between the SS total to SS between group. We can able to calculate the SS within group. This is the value. So we have between group, within group, total. So degrees of freedom also we know. Simply we can able to make the F table. The ratio between SS to degrees of 192.2 divided by 2, 1100.6 by 27 will give this value. Then between these two ratio we get 2.35. This is the F calculated, F critical from the table for the 2,27 degrees of freedom. Again the same value. So this is method number 2. Okay. So method 2, I hope you guys are clear compared with the method 1. Okay. So next video I am going to make for two-way ANOVA problem. Okay. I am closing this.